Hello everybody. So in today's lecture we are going to discuss about the graphs in this chapter. All right. So basically let us first discuss the position time graph. Okay. So that would be our first graph, number 1, position time graph. All right. And here you should know one thing, okay, that the slope of this graph at a particular point represents the instantaneous velocity. Okay, so the larger the slope, the larger the instantaneous velocity at that particular point. So that is basically what it means. Okay, so let us discuss the first graph, which looks something like this. So here we plot the position along the y-axis and the time along the x-axis. Okay, so this will be x represents the position, t represents the time. All right, so the first graph is just a line that is parallel to the x-axis. All right, now here what is the slope basically? What is the slope basically? The slope is nothing but the tangent of the angle that the graph makes with the x-axis. Now if you look at this line here, it is parallel to the x-axis. So what angle does this line makes with the x-axis? So here the angle theta is 0 degree. So therefore slope is equal to tan theta. So this is tan 0 degree, which is 0. But then what does the slope represent? It represents the instantaneous velocity. So therefore velocity of the body is equal to 0. And if the velocity is 0, then we can say that this body is stationary or not moving, right? So that is the body is at rest. Is that clear? So whenever you see this kind of a graph, you can say, and mind you, it should be an xt graph. So that means that the body is stationary or at rest. Okay. Right, so let us discuss the second graph, number 2. Let's say we have again always the position is plotted along the y-axis, the position x, and time is always plotted along the x-axis. Now let's say the graph is like this. Okay. This is the angle that the graph makes with the x-axis. Now at every point, this angle is at this point at the origin. Now if I draw a line from this point, let's say parallel to the x-axis, it would make this angle. At this point, let's say parallel to the x-axis, it would make this angle. So at every point, if I draw a line parallel to the x-axis, do you agree or not that this angle will always be the same? It will have the same value. Yes, so that means the angle theta here is constant. Okay, so therefore slope which is equal to tan theta, this will be constant because tan of a constant is constant. So if the slope is constant, then we can say that the velocity is constant. So the body is moving uniformly. Is that clear? So let's go to the third graph, number 3. Let's say our graph is like this. position, time, this, and a graph is like this. Okay, so this at the origin it makes an angle theta. Now what we will do is, just for our understanding's sake, we are going to plot, we are going to draw imaginary lines parallel to the x-axis. Now if at this point if I draw a line parallel to the axis, I will get this value of theta. At this point, this is the angle. At this point, this is the angle. And do you see or not that the value of theta keeps on decreasing? The angle keeps on decreasing. So here we can say that theta decreases. Okay, if theta decreases, what does it mean? Okay, if theta decreases, is decreasing with time, right? So therefore slope decreases with time. That means velocity decreases with time. So this is a non-uniform velocity. Okay, so it is a non-uniform velocity, and since the velocity is decreasing with time, this is retardation or negative acceleration. Okay, the body is slowing down, right? The body is slowing down, isn't it? So we can just say, yeah, we can just say that it is retardation. Okay, got it? Okay, so let's go to the next page. This is number 4. Let's say we have a graph that looks somewhat like this. Okay, so this is the angle theta. You can see that angle theta is small, and if I draw a line like this angle theta increase. If I draw a line like this, the angle theta increases. So you can see that theta increases with time. Okay, theta increases with time, so that means slope increases with time. Okay, slope increases with time, so that means velocity increases with time. So is it a uniform or non-uniform? This is also non-uniform velocity, and since velocity increases with time, this is acceleration. Understand? That's acceleration. So number 5. Let's say a graph which is like that. Okay, so what will be the value of theta? Now the value of theta is this. This is theta. Okay, so here theta is larger than 90 degree. So therefore tan theta, this will be negative. Tan theta, this will be negative. So therefore velocity is negative. Velocity is negative. But then if you look at the slope is constant. Negative but constant. Okay, so this is also uniform velocity. Is that clear? Right. So that is the velocity, the position time graph. Let us now discuss the velocity time graph. So this is number 2. velocity dash time graph. Okay, and again here, what does the velocity time graph represent? So the slope of this graph at a particular point, represents what? Represents acceleration or instantaneous acceleration. Okay, so let us go to the first graph, number 1, and let's say our graph looks similar to the graph that we drew for the first time. Now this is velocity time graph, and always the time is plotted along the x-axis, and now along the y-axis we plot the velocity. Okay, and the graph is somewhat like this. Let's say we have just a line which is parallel, right? So again here theta is 0 degree, so therefore slope here will be 0. And what does the slope represent? Now it represents the instantaneous acceleration. So therefore acceleration, this is 0. Okay, so the body is moving with 0 acceleration, meaning what? Meaning it is moving with uniform velocity or uniform motion. Got it? Number 2. Let's see now. Okay, we are going to draw similar graphs to the one that we drew before. Okay, so if the graph is like this, then theta here is constant. So therefore acceleration, so tan theta, first of all, it is constant, right? So slope, if the slope is constant, so therefore acceleration is constant. Got it? So this is uniformly accelerated motion. Uniformly accelerated motion. Sorry, not x, this is v t. Okay, if it is like this, if it is like that, then here theta is decreasing. Sorry, I forgot the spelling of decreasing. Decreasing with time. So therefore slope is decreasing with time. So therefore acceleration is decreasing with time. Okay, so if the acceleration decreases with time, so does this mean that it is retardation? This is not retardation. Basically the acceleration goes on decreasing but with time, but not retardation. Next page. What number was that? That was number 3. So now it will be number 4. Number 4 again. Velocity time. If it is like this, then theta increases with time, so that means slope increases with time, so therefore acceleration increases with time. Okay, it goes on increasing with time. And then finally, number 5, we have a graph velocity time graph, and the graph is somewhat like this. Okay, so this is the angle theta here. So here theta is more than 90 degrees, so therefore tan theta, this will be negative, right? Negative. And that means slope is negative, so acceleration here is negative acceleration. So if it is negative acceleration, then this is retardation. Understand? So here, when even though suppose in number 3, right, in number 3 here, we can see that the acceleration is decreasing with time. Okay, even though it is decreasing with time, but then it is positive. Okay, so therefore such a graph in which the acceleration is decreasing but still positive, that is not retardation. And if you look here, this acceleration is it decreasing with time? The acceleration here is negative, but it is constant. Okay, it is negative but constant. So because the acceleration here is negative, this is retardation. Okay, now what about the area of this graph? What about the area? This will be number 6, I suppose. Yes, that's 5. Yes, so this is 6. Area of VT graph. Area of VT graph is given by this integration of V dt, right? V dt, and this is equal to the displacement. That means the change in position. Okay, so these are the graphs that you need to know. And lastly, let us go to the acceleration time graph. Okay, we have done position time, we have done velocity time. Now number 3, this is acceleration time graph. Okay, and let's draw this graph, number 1. Okay, first of all, what does the slope of the acceleration time graph represent? Okay, so here, right, the slope carries no meaning out here. So let me just write down number 1. If suppose the graph is something like this. So now we are plotting acceleration along the y-axis and time along the x-axis. Okay, if the graph is like this, then if the graph is like that, right? So here theta, this theta here is constant, so therefore acceleration here, this will be constant, or uniform acceleration. Okay, uniform acceleration, and you can see that the acceleration is increasing with time. Uniform acceleration or uniform increasing acceleration. Number 2. If suppose it is something like this, then you can see that the acceleration is constant, right? So here acceleration, this is constant with time. Okay, so that means it is uniform or constant acceleration. All right, so these are the graphs that you need to understand. Okay, they are not very difficult to understand. All you need to know is in the xt graph, the slope represents the instantaneous velocity. Then depending on the slope, if the slope is 0 or constant or negative increasing or decreasing. Similarly, the velocity will be 0, constant, increasing or decreasing. Then in the VT graph, the slope represents the acceleration. So same condition, depending on the slope, the velocity also will change accordingly. And then we have the acceleration time graph. The acceleration time graph, it just represents the variation of acceleration with respect to time. Okay, so please learn these graphs nicely.